So far in maths class, I've just given you sine and cos values for these two special triangles, the 30 and 60 degree triangle and the 45 degree triangle. But now I want to prove those values for you. So first we'll take the 30-60, and first what I want you to do is consider an equilateral triangle like so, where all sides are of length 1. Now we know from equilateral triangles that it has three equal sides and three equal angles. So each of these angles must be 60 degrees. And what I want to do is I want to bisect this particular angle here and come down here, and this makes a 90 degree angle down here, and so this one here must be 30 degrees. Each of these sides must be 30 degrees. And because the length of this whole bottom side here is 1, the length of each of these halves must be 1/2. And so let's now just have a look particularly at this triangle here, and this is our 30-60-90 triangle. And so if I was to take this angle here, this 30 degree angle here, we know that the sine of an angle of sine 30 degrees is the opposite over the hypotenuse, and so the opposite is length half, the hypotenuse is 1, so therefore sine of 30 degrees is equal to 1/2 over 1, or in fact it's just equal to 1/2. And so this is proof that the sine of 30 degrees is equal to 1/2 if the hypotenuse obviously is 1. And now we need the cos, but for that we need to know this length of this side here, and now this is going to be Pythagoras is going to help us out here. So Pythagoras will tell us that the length A will simply be the square root of 1 squared minus 1/2 squared, which is the square root of 1 minus 1/4, which is obviously the square root of 3/4. And the square root of 3/4 is equal to root 3 over 2. So this side length here is root 3 over 2, and therefore cos of 30 degrees is equal to adjacent over hypotenuse is equal to root 3 over 2 divided by 1, or in fact that's just root 3 over 2. Now let's have a look at the this 45 degree angle here, and let's assume that the hypotenuse is 1. And this is this particular triangle is an isosceles triangle, and an isosceles triangle has the features where two sides are of equal lengths, and the base angles, which would be these two 45 degrees here, are of equal size, and so therefore we know that these two are of equal length. So let's call this A and this length A, and Pythagoras will tell us that A squared plus B squared, which is another A squared of course, that this squared plus this squared equals this squared, that is equal to 1, or 1 squared, which is 1. And so 2A squared is equal to 1, A squared is equal to 1/2, so A is going to be the square root of 1/2. And the square root of 1/2 is simply 1 over root 2. And I'm going to rationalise the denominator by multiplying by root 2 over root 2, and this is going to end up with root 2 over 2. So we know that each of these side lengths here is root 2 over 2. And now we can see that sine of 45, we'll take this 45 degree triangle here, this 45 degree angle here, the sine is the hypotenuse, which is root 2 over 2, the sine is the opposite, root 2 over 2 over the hypotenuse, which is 1, so the sine of 45 is root 2 on 2, and by the same reasoning, the cos of 45 degree is also root 2 over 2. So now we have the values which we just were given in class, and we can see that the cos of 30 degrees is root 3 on 2, the sine of 30 degrees is 1/2, and the sine and cos of 45 degrees are root 2 over 2.